for the first question, this lesson is on graphing piecewise functions. Does anybody think they know what piecewise represents? Why would it be called a piecewise when I look through at these functions?
Maybe piece sign.
Oh no, not piece sign. There are different pieces to the function. There's multiple. There's not just one simple equation. There are, how many for this one? There's 3 for this one, 2 for that one, 3. They're split into separate pieces. So for the x plus 3 section, I'm going to build a table. For this piece of the function, it says to start at 0, that x is less than or equal to 0. So if I go 0, what number is to the left of 0 on the number line?
-1.
Yep, -1 and -2. Then before I start plugging anything in, I want to check what type of dot I need to start with. Kind of weird. Because this is an equal sign by that 0, this will be a closed dot when I graph it. I do not need to check any other numbers. I only need to check the number that is in the inequality statement. Then I plug in. What is 0 plus 3? 3. What is a -1 plus a 3? 2. -2 plus a 3? 1. I can then go over here and graph. 0 is up 3. I click and make sure it's a closed dot. -1 is up 2. -2 is up 1. What shape is that making? Straight line. Yeah, it's making a line. I'm just going to kind of fill in my dots to help fill the pattern. There's one piece. One piece checked off. Done. Second piece. My second piece says that I have the number 3 for my equation. And it goes from 0 to 2. 0, 1, 2. 0 to 2. I need to check what 0 is. 0, because there's no equal sign, will have an open dot. And then I look at the 2. The 2 is also in my statement up here. Will 2 have an open or a closed dot?
Close.
Look, it's equal. Closed is correct. Good job. I only check the numbers that are next to my inequality signs. They're the only ones I need to double make sure. Is there anywhere to plug a number in the equation? Nope, there's no place to plug it in. So if I go try to plug a 0 in, there's nowhere to plug it. I get the answer 3. When I go to try plug a 1 in, nowhere to plug it, I get a 3. I try and plug 2 in, nowhere to place it, I get a 3. Just always 3. That's the constant. It'll always be the number 3 in my list. Easiest one, yet the hardest one to remember. 0 is up 3, it would be an open dot. 1 is up 3, and 2 is up 3, closed dot.
Wait, what's number 1? 1, is it just that we're just not, is it closed or open?
1, we don't have to check the question. We don't have to check the 1 because there's no 1 written in my inequality statement. So it's just part of the solid line. So it technically is closed within it. My last piece says that I have 2x minus 1 when x is greater than 2. Numbers that are bigger than 2 or to the right of it on the number line would be 3 and 4. I check 2 because there's no equal sign. 2 is an open dot. I don't need to check any other values. I only need to check the 2 because it's part of my inequality. When I plug 2 in, 2 times 2 is 4. Take away 1. Plug a 3 in. 3 times 2 is 6. 6 take away 1. 4 times 2 is 8. 8 take away 1. 2 is up 3. It's an open dot. 3 is up 5. 4 is up 7. That's a piecewise function graph. It's okay if you have an open dot and a closed dot overlap. Really fine. It just ends up filling it in on your graph. Let's try the second one. I only have 2 pieces, which means I will only have 2 parts to my graph. I'm going to start with the top one. I start with the number -2, and I look for numbers that are to the left of -2. Left of -2 on a number line would be -3, -4. When I check my first starting number, it is equal to it, so I'm going to have a closed dot. All of this information came from this inequality. I now plug that in for my table. -2 times 3 is -6. -6 plus 5 is -1. -3 times 3 is -9. -9 plus 5 is -4. -4 times 3 is -12. -12 plus 5, -7. I graph it. -2 down 1. Then down 4. Then down 7. You'll notice it's going down by 3s. And I only go down. I'm not going to fill in up top. I just go from -2, -3 to -4. And I continue it. For my second piece, I have x minus 4 when x is greater than 2. That means I start with 2. Numbers to the right of 2 would be 3 and 4. There's an open dot for the 2 because it's not equal to it. I plug in 2 minus 4 is -2. 3 minus 4 is -1. 4 minus 4 is 0. 2 down 2. Open dot. I'm almost filled up. 3 is down 1. 4 is at 0. As I fill in my graph, I need to make sure that this is an open dot. I almost filled it in on accident. But that dot is open. The rest are a solid line, part of your line. Any questions? Question 3. First piece. I have 2x minus 1 when x is less than or equal to -2. I start with a -2, and I go to the left of it. So left of -2 on my number line would be -3 and -4. -2, because it's by my inequality sign, I check it's equal to it, so I will put a solid dot. Bless you. I plug it in. 2 times -2 is -4. -4 minus 1 is -5. Plug a -3 in. -3 times 2 is -6. -6 minus 1 is -7. -4 times 2 is -8. Minus 1 is -9. -2. 1, 2, down 5. 1, 2, 3, 4, 5. Close dot. 3 is down 7. And then 4 is down 9. My middle equation. These ones are the nice ones. I have the number 4 when x is between -2 and +3. -2, -1, 0, 1, 2, 3. -2 is an open dot because there's no equal sign. I check my 3 is a closed dot. I do not need to check any of the middle. They'll be filled in by my line. When I try and plug in, there's nowhere to plug. There's no x value. That means my answer will always be 4. So I try to plug -2 in, won't go in. Answer's 4. -1 I try to plug in, won't go in, 4. All of those values will be a 4.
Why are there so many?
I just put all of the numbers between -2 and 3. You don't have to. You could just plot the point -2 up 4 and put an open dot. +3 up 4, put a closed dot. And then because you know it's always a 4, you know it's a solid line. I just put all of them in because it helps. Some people like to be able to see that every point is at 4. You don't have to. Third equation, I have -x plus 2 when x is bigger than 3. Numbers greater than 3 would be 4 and 5. This will be an open dot for the 3 because it's not equal to it. I then plug in -3 plus 2, -1. -4 plus 2 is -2. -5 plus 2 is -3. 3 is down 1, open dot. 4 is down 2. 5 is down 3. And if I continue my pattern, next graph, I have 2x plus 3. When x is less than 0, numbers that are less than 0 would be -1 and -2. 0, because it's not equal to 0, I will place an open dot. Plug in. If you are struggling to follow along when I plug numbers in, you would just type in your equation, 2x plus 3, replace the x with a 0, then replace it with a -1, then replace it with a -2. You don't have to do it in your head. I plot my points. 0's up 3, open dot. -1 is up 1, -2 is down 1. If I continue my pattern, on your online assignment, it's nice because you just click open dot, click here, and it should autofill your line. But when I'm graphing by hand, sometimes it helps to continue the pattern so that I hit the correct points. I have 3 minus x when x is greater or equal to 0. So I have a 0. Numbers bigger than 0 would be 1 and 2. When I plug them in, if you want to use your calculator, I would do 3 minus parentheses for the x. I go to the parentheses and fill in a 0. I fill in a 1. I fill in a 2. Zero is a closed dot. 0, 3. I end up filling this closed dot in. 1 is up 2. And 2 is up 1. If I continue my pattern, there's my second piece. Once you have that filled in, turn the page. We have one ACT question on the back. And an application problem.
We're gonna have the ACT question on our test.
ACT won't be on the test. The only things that will be on the test will be the new material. I just pull them directly from your assignments. All right, for this question, they give us 3 pieces. When I do the first one, remember this is an ACT, you do the ACT next year. So that means these harder questions, they're gonna be a little bit harder. I go from -3. Numbers to the left of -3 will be -4 and -5. It is an open dot on -3. I'm going to type in my equation. I have my parenthesis, blank, +4, closed and squared. Then I would plug my value in here. I'm going to do it with you in our heads. Let's see. What is -3 plus a 4?
1.
1. What's 1 squared? What's 1 times 1? What's -4 plus a 4? 0. 0 squared?
0.
0. -5 plus 4 is -1. What's -1 squared? Ooh, careful. -1 squared.
Positive 1.
-1 times -1 makes a +1.
Yeah.
It's a sneaky. And if I wanted to check, right, we can always, when I plug -3 in, it's a 1. -4 is 0. -5 is a 1. So I'm going to check. Where is -3 up 1 an open dot? -3 up 1, is this an open dot?
No.
Nope, wrong. -3 up 1, is that dot up 1? Nope. -3 up 1, that one works. -3 up 1, this point works. What about -4, 0? Between these two,
Right. E.
this one, -4, 0. Is there a point right here?
Oh, I was looking.
-4, 0. -5 up 1. I can plot one piece and figure out which graph it matches. I don't have to graph all of the pieces for a multiple choice. So you can go quicker through the math problems by focusing on one piece. If, let's say, it didn't help me get rid of a few of the answers, I could always check a second piece. -3, -2, -1, 0, 1, 2, 3. This is a closed dot. This is an open dot. 2 times the number. 2 times -3 is -6. 2 times -2 is -4. Times by 2, times by 2, times by 2, times by 2. I check. -3 is down 6, and it's a closed dot. +3 is up 6, and it's an open dot. So this line matches. If I had checked, this does not match in the center. This one, why does B not match my table? Both are open dots. One needed to be closed. Good. So there's, and then this one, same thing, no line in the middle. So just by checking the one central piece, I eliminated those 3 answers and came to C. Last question. We are not going to graph it. We're just going to talk about using the function. There was a graph. So you have a summer job that pays time and a half for overtime if you work more than 40 hours. After that, it is 1.5 times your hourly rate of $7 per hour. Does anybody have that in their job where they get paid overtime? Yeah. So this is a function we are using to represent our work hours. You'll notice if you work 40 hours, how much are you paid? $7 per hour. That's the first piece of the function. But as soon as you go over the 40, you gain a new piece. You get time and a half. That's where the 10.5 comes from. So it asks, how much will you make if you work 45 hours? There are different ways to do this. Does anybody have an idea?
Plug in 45.
Where I have, it's a piecewise function. I have 2. Where would I plug it in? For H? In this top one or in this bottom one? Why the bottom one?
Because you go over 40, you have to go the other one.
So the overtime question. Okay, so if this is the overtime question, let's see how much we would make if we went to work for 45 hours in 1 week. So 10.5 times 45 minus the 140, we would get $332.50 for our paycheck for that week. How much will we make if you work 60 hours? Which equation would I substitute the 60 in? Bottom, overtime again. I'm just going to go in get rid of the 45 and make it a 60, I would make $490 that week.
And if it was under 40, you just plug it into the top one.
Let's check. So that's a great question. What if you work under 40? So then let's say I work, how many hours would you work? Does anybody work in here? How many hours do you usually work?
Like 8.
8 hours a week? Anybody else about that? Ish?
Oh, a week?
A week, just 1 week.
Oh.
Let's say 19 hours. If it's 19 hours, then I would no longer plug it into the overtime. I would then substitute it into the top function, which means I would do 7, plug in my 19 hours. Then I would get 7 times 9 is 63. 7 plus 6 is 13. I'm gonna double check. 7 times my 19 hours is $133 per week. So that's kind of how piecewise functions work. When income or when something's adjusted, it applies for both. Any questions? All right, you have the rest of class to do your assignments. I will move it onto the board and do some of the problems with you if you have questions.